Hey everybody, this is Mike from Rebel and Trains, coming to you today to give you a soldering tutorial. These are techniques I picked up over the years from RC car racing and also my time in the Navy doing electronics. I've learned quite a bit about soldering, and I would like to share my knowledge with you. The techniques today, in my channel is primarily a model railroading channel. The techniques I am going to show you today will work for any type of electronics, the Arduinos, RC cars, model trains, you name it. This is soldering 101, not a particular hobby type soldering. I imagine even if you're into stained glass that my techniques would work even for stained glass work. So, that being said, let's get started. Alright, first off I'm going to show you some of the tools that I have here. First off is my solder station, and this one has a hot air soldering iron, which is what this is. It's also a heat gun. There are some tips that go on here to change the amount of airflow. I don't typically need to use the hot air soldering abilities of this, but I do use this for heat shrink, as you've seen in my wiring harness module. And then there is the solder iron itself. It's a pretty typical soldering iron. It looks like a low wattage iron, but actually this thing gets quite hot. Now I chose a solder station over just a standard iron, so it gets control of my soldering temperature, my hot air temperature. I don't know if you guys can see that. Let me see if I can get. But it gives you the choices to choose from that. It also gives you a choice for the airflow. I typically have everything I have here set to max. There's a reason for that I'll discuss more in a minute. This here gives me the actual temp of the hot air gun, and this is the actual temp of the, actual temp of the soldering iron and actual temp of the hot air gun. There's little sensors in them, and that's the soldering station that I use. The other tools I use, again, you've seen this before, is the wire strippers. These here are my favorite style. You just pinch the wire in between here and it does all the work. They're automatic. I will show you that as we go through the demo. My solder of choice is standard 6040 rosin core solder from Radio Shack. I know Radio Shack's stores are closed, but they still have an online presence. You can still buy this today. This by far has been the best solder I've ever used. And I also use some paste Flux. This is an old bottle. It has been around for a while. There is no UPC on it. It is probably from the late 60s or early 70s. My dad gave it to me, and it's about half full right now. I'm going to be needing some soon, but in the meantime I'm going to keep using this. Kester does still make solder paste Flux, and there are many other brands out there that do the same thing. I prefer the paste over the liquid. The paste tends to stay in place a little bit better. So those are the basic tools. Today we're going to solder together this little Arduino breakout board to show you how to solder onto a PC board. And I'm also going to demonstrate tinning the wires, and also I'm going to combine these two wires together in a to show you how to solder two wires together. So that'll be the basics of the soldering today, and let's get started. Okay everybody, here we go. So first thing we want to do is get everything prepared. I like to get everything prepared for the job all at one time. So in this case I've split the wires, and now it's ready to tin them. Well, I have another one that I need to split to get ready for tinning. So I'm just going to take in this case I can use my fingernails to break them apart. Sometimes you'll have to use a pair of cutters and split them down an inch or two. Now we need to strip the ends off of them. This is where this tool comes in really handy. I do apologize about the shadows. Alright, let's see if that works a little bit better for the shadows. You know, looks like the blue is easier to see, but the white's now washed out. So with this tool, what you're going to want to do is there's individual little grooves, and now you can't see them at all. There you go. So each of these has grooves for different size wires. And that way you can pick the right one for the job you're doing. In this case, it's going to be the smallest one way over here in the corner. So usually you strip about a 1/4 inch of wire or so and squeeze them together. And when you're done, let's see if it adjusts for the different light. There we go. And when you're done, you get 1/4 inch stripped wire. So at that point, you take and twist them together. Really get a good tight twist in them. That way the strands don't come free. And do it again with the next one. Alright, I got one wire set ready to be tinned. You see that there? Alright, let's get the next one done. Alright, I made a little adjustment to the lights, so hopefully it's not as bad. There's still shadows, I can't help you with that, but at least I don't have as harsh as shadows. Alright, so going for the second wire here. Again, we're going to trim about a 1/4 inch off of each one. And we're going to twist the ends together so they're nice and tight. Alright, so there we go. So next, looks like you got one of the little bits fell into the solder paste here. There we go. Alright. Next we're going to take and dip the wires in the paste. Just dip in, dip out. Doesn't take much, it just needs a little bit on there. Now one of the things that's key to soldering is getting all the stuff clean. Now it may look clean to you and me, but it doesn't necessarily mean it's clean to the solder, which is what this accomplishes. This cleans the wire so that the solder can stick to it. Get that where you can see it. So next up we're going to turn the soldering iron on. And when it comes to soldering, you don't want to generate a lot of heat. So logic would say use the cooler soldering iron. Well, I have found the key to not using a lot of heat is to get in and get out, and get in and out quick. So in that case, use the soldering iron at its hottest setting, and then the solder will melt, it'll do its job, and you can get in and out quick. There will be less heat transfer than if you use a lower temperature, but you have to sit on the part longer for the solder to flow properly. Okay? So next what we're going to want to do is once the soldering iron reaches the maximum or the optimum temperature, we're going to want to make sure that the tip of the iron is clean. Now to do that, we're going to have to use a little sponge. Here, give me a second and I'll show you what I'm talking about. Alright, well here's my soldering iron on this little stand. Here's the sponge I was talking about. So this is just a cellulose sponge. It's damp, not soaking wet, and all I need this to do is to clean the carbon off the end of the tip of the soldering iron. Now I prefer the cellulose sponges over the natural sponges. The natural sponges don't tend to handle the heat as well. And if you take a look at my iron here, let's get some good light, you can see how dirty the tip is. Now right now my iron's hot. There it is there. You can see the temperature is at 480 degrees Celsius. That's the hottest this iron will go. So to clean it off, take and swipe it around there really quick, and now you can see the tip is bright and shiny. So you need to do that just about every time you're going to dip the iron into the thing, and you can already see it oxidizing a little bit just in the time we've talked here. So it doesn't take it long for it to, start to build up that carbon again. So yeah, right before you're going to dip it in the solder, give it a good swipe real quick. That's all you have to do. And there you got a good clean tip to start with again. What you don't ever want to do is you don't want to dip the iron into the flux. It will clean, but at the same time it'll leave a bunch of carbon behind that will prevent you from sticking any solder to the tip of the iron or to the work that you're trying to do. So now let's get you back up on the tripod so we can demonstrate how to do the tinning of the wires. Alright, here we go. So I know the soldering iron's off camera right now. That's not that important. What you're going to want to see is what I'm doing here with the wires. So these have already been dipped in the flux. There's a little tiny bit of flux on them. Here's rosin core solder. The flux, I believe, is a rosin based flux as well. Acid flux works just fine. The problem with acid flux in the long scheme of things is it needs to be cleaned thoroughly off of the work you're doing. If there's any moisture that gets on the work after the the acid core flux is used, it will cause corrosion. It is an excellent cleaner. It does do the job. It is just difficult to make sure that you get all of it cleaned up, and so it no longer works. It's magic in corroding your project. Rosin core, on the other hand, is an alkaline, and it doesn't tend to mess up the work that you're doing. So let's get started. I'm cleaning the tip of the iron. Now I'm going to add a little bit of solder to the tip of the iron and touch the wire. There'll be a little smoke coming off of it. I don't know if you can see that really well. Let's do it again on the other one. And then when you're done, you can see the wire is now nicely coated with solder. And that was in and out really fast. There wasn't any loitering. The wires are not hot. I can touch them. And I just had a hot iron on them just a couple seconds ago. So that's the reason why I use the iron at the hottest temperature possible. I can get in and out quickly. I don't transfer much heat to the work that I'm doing. So let's do the other two wires here. Still got a little solder left on the tip. There you go, in and out quick. Try to get that little solder blob that fell. Nope, it's not going to do it. And there I go. Once again, in and out quick, and I can touch it. It's not hurting my fingers. That's the whole point I'm trying to make here, is you get the solder really hot, or the iron really hot, excuse me. It's in, it's out, very little heat transfer into the work, and it's going to apply for the circuit card as well. If you get the circuit boards too hot, they will start to delaminate and the traces will come up off of them. So as you see here, this is a really simple circuit board, but there are still these individual traces that go out to the breakout board. If you get those too hot, they will disconnect from the fiberglass board that they're built onto. So we'll get to this here in just a minute. Now, one of the most common solder jobs that you're going to do is you're going to be combining two wires together. So there's many ways of combining wires. You can actually intertwine them and weave each wire together and then solder them. That's very technical, very difficult to do, and for the purposes of our model railroads, unnecessary. Usually if you just lap them together, so this would be a lap joint. If you just lap them together, overlapping them, usually the full distance, and the solder will take hold and combine the wires into one. If you connect the wires end to end like this, that would be considered a butt joint. It's not very strong, that's why you would weave them together. But in this case, we're just going to do a lap joint. So, if you have helping hands, this is the point in time where you want to use them. I unfortunately do not. So what I usually do is I secure one item to the table with a heavy tool, and then I hold the other one in my hand so I can manipulate it where I need it to go. So let's get that set up. Okay, here you go. So as you see, I'm using my crimp tool to hold this wire here, and now that allows me to run this wire and touch and do what I need to do to get a good solder joint. In this case, I manipulated a little bit so it'll give me just the angle I need, and then I will be lapping them together like that. So once again, clean the solder tip, add just a touch of solder, and then touch them to the wires. And there you go. It's that easy. Once again, I can touch the wires. They're not hot. So let's change it around so I can get the other side in. Now the second one's going to fight me a little bit more because, you know, it's now attached to the other. It's not completely free, but same concept applies. Clean the tip, add a little solder, touch and go. And there you have it. These are, I'm pulling on these actually quite hard now. These are good, strong solder joint. At this stage, you would use a heat shrink tube over them or some electrical tape, just keep them from connecting, you know, touching each other and causing a short. But here's the wires now. Whoops. Get back into focus. Come on, focus. There we go. So now these wires are permanently combined in a lap joint. Again, like I said, if it wasn't for this demonstration, I would have some heat shrink tube that I would be sliding over there and then heating it up. But because it's just a demonstration on how to solder, not on how to heat shrink, here's where we go. Alrighty, so now moving on. This applies, before I actually move on, so thicker wire is obviously going to take more solder. It's going to take more time. I have a piece of my 16 gauge silicone wire. This is the same wire that I use for my my wiring harnesses. So it is about 4 times thicker than those 2 wires there. It will take a slightly different technique to tin this wire. So what I'm going to do, again, I'm going to take off about 1/4 inch of the insulation. Again, I'm going to twist it down as tight as I possibly can make it. This just helps prevent the strands from fraying out and, you know, getting all loose and wild on you. Here we go here. Let's just dip it in, take it out. Now in this case, one of the strands came undone. Just take and tuck it back up in there. I'm gonna try to do it best you can. I got a little flux on my fingers, no big deal. Stuff's not toxic. So in this case, I'm going to set up the solder. So the solder is kind of giving me a little workbench there. And not a workbench, but kind of like the wire in the tool here. The solder is now just being supported up. I put a little bit on the tip and get it started. Now this is going to take more than what the iron can hold. So I can use the iron and the wire at the same time. And there you go. Now this one will be a little hotter because the iron was on it a little bit longer. But again, it's not exceptionally hot where it won't cool down in just a minute or two. Yeah, it's a little warm, but it's not bad. It's definitely a lot quicker than had I taken and tried to use the flux that's inside of the solder to both clean and apply. I would have been on this wire about twice as long as I was. So there we go. Now when it comes to circuit boards like this, and these are the pieces that go to build the circuit board, the technique is very similar, not exactly the same. So with these small pieces here, I can dip them directly into the flux and then put them onto the board. They're actually going to go on the board this way, and then I will have my flux up on the board. You get larger pieces such as this that won't fit into the flux as well. You just use a small screwdriver and apply a little bit of flux to each of the pins before you put it in here and solder it down. So we're going to start with putting this piece here, which is the piece that holds the Arduino, and we're going to put that into the board. I'm going to try to dip it and see if I can get all the pins. I get all but one. There we go. So I was able to get all the pins using that method. And I put the piece into the board. Now we need to flip the board over. Now when I do this, because of the nature of this particular piece, I'm only going to solder one solder joint at the moment. I'll zoom you in here in just a second, but a little bit of solder on the card, touch it to the pin. Okay, now it's not a good joint yet, and I don't want it to, and the reason why I don't want it to be a good joint yet is you see how the angle is wrong there? This allows me to heat it up once again, and get it positioned perfectly vertical. Now if you're using a dual inline pin chip or a resistor or something, you probably won't have to do that. So let's move on. And let's get you zoomed in here so you guys can see a little bit better. Alrighty. So for this I'm going to position it where it's comfortable for me to use. Take and clean that tip off. It is a little dirty. Touch some solder onto it. And we're going to touch a little solder and a little iron at the same time. Now with this, I'm not going to stay on one side for too long, because I might not be on the pins for very long at all, but the heat will be right next to each other as we go along. So hopefully you can still see this. There we go, and this one wasn't a very good joint to begin with, so let me improve that a little bit. There we go. So now what you see here, let's see if we can, is all the solder is on the pins and on the little contacts on the board as well, all at the same time, and none of them are shorting. That's a key. If you need to double check it, you can always use a multimeter and check pins that are right next to each other. Just go across, each pin that are next to each other, all the way down the board. But this is not very hot. I mean, because I did do the, what is it, 16 pins all down one side, it did get a little bit warmer than the wires did, but it is still not obscenely hot. I can still touch it. I'm touching the contact here. It's warm to touch, it's not burning myself hot. And that's what you're looking to do. Alright, well I'm going to finish up the rest of it, and you will probably see this in high speed. All right, there we go. Got the other side done. Now I just got to get the screw terminals and put these into place. I'm not going to bore you guys with that. It's more the same exact thing I just did. Dip them into the flux, put them into the board, and then run the solder down. Okay guys, well there you go, my little quick and easy tutorial on how to do soldering. I hope you all find that helpful and that you can make something of the video, and hopefully it improves your soldering skills. Like I said, these are not the only methods of soldering out there. These are just the techniques that I have found that over the years has helped me successfully solder many different components together, from anywhere from wires to transistors to IC chips, lots of different things throughout my tinkering, because the best way to put it is tinkering. I like to tinker with electronics. So hopefully you can put the lessons in this video to use, and if you have any questions or comments or anything else, go ahead and put that down below. Again, like I said, this is not all encompassing. It is not every single method out there. It's just the methods that worked for me, and hopefully they'll work for you. Thank you very much, and I'll see you on the next one. Okay, first off I'm going to show you some of the tools that I use here. This is my solder station.